So let's review this. What are we talking about? Here we go. So we're using this bicycle context to help us when the argument in the sine or cosine is more complicated than just theta, right? So if it's sine theta or cosine theta, it's a breeze, right? But so if we have cosine of a function of theta or sine of a function of theta, this is kind of our starting point to talk about that. So what was theta was the pedal angle measure, and that's like going to be like the input of the function. And from that, we got the tire valve angle measure. And then from that, we could monitor some aspect of the tire valve's position. So this was the kind of the sequence that we're looking at. So based on an angle of rotation angle measure of the pedal, the tire valve will have a certain angle measure of rotation, and then that will give us the means to find that some aspect of the tire valve's position. Okay. So this is what we're talking about, right? So the tire valve angle measure is a function of the pedal angle measure, and the tire valve position is a function of the tire valve angle measure. So this is a composite situation, right? Composite function. We start with an angle measure for the pedal, we get the angle measure for the tire, and then we can get a position, something about the position. Okay, so then it looks like this. So the output of the function is the sine of g theta. And what quantity is that in this situation? What quantity is sine of g theta? Pedal angle measure, tire valve angle measure, or tire valve position? Yeah, which position? What aspect of the tire valve's position is this? Vertical distance above the horizontal diameter, okay? So if we want that thing to be about the tire valve position, then what about the argument? Pedal angle measure, tire valve angle measure. Gotta be the tire valve, right? If we want sine to tell us something about the tire valve, we have to give it something about the tire valve. Namely, the angle measure. And then sine will give us the vertical distance, right? Okay? But that tire valve angle measure we saw was based on the pedal angle measure theta. So when you model with sine and cosine, this is very common. You have sine of a function of theta or cosine of a function of theta, the argument. And so this is kind of, we're using the bicycle as a very simple way to kind of make sense of what's going on when you have these composite functions like this. So let's do one more example. So on page I think it's 285. Nope, page 287. Number 3. Is that what you did in recitation on Tuesday?
Yeah.
Thursday? Yeah. So did you use pi over 6? You didn't change the problem? Okay, so we'll change it to, change that to sine theta, and we'll say that the tire valve on the wheel is pi over 3 radians counterclockwise from 3 o'clock. So I'll show you that with my animation here. So change it, we're going to use sine. So here's what that looks like. So when the pedal is in its starting position, the valve is already rotated pi over 3 into its cycle, if you're starting from the 3 o'clock position. And then as the pedal rotates, what's the position of the tire valve relative to the pedal? Always. How could you describe the position of the tire valve relative to the pedal in terms of angle measured? How could you describe that?
3 radians ahead of us.
What is it?
3 radians ahead.
3 radians ahead. So I like the ahead. Yes, I like that the tire valve is ahead of the pedal, but so now how many radians ahead?
1.2.
Was it? Pi over 3. How I told you to change the problem, right? It's now pi over 3 ahead instead of the problem says pi over 6. Okay, so let's write the our blue function will be call p of theta for pedal, and we want to do the vertical position above the horizontal diameter of the pedal as a function of the pedal angle. What function is that? Sine theta. And then if we want to write the tire valve, its vertical position above the horizontal diameter, but as a function of the pedal angle, what does our argument need to be? So our argument needs to be the angle of the tire valve or of the pedal? Tire valve. Okay, so this argument angle has to be the tire valve angle as a function of the pedal angle. What is it? Yeah, Faisal. Yeah. And why? So why plus? Why does plus make sense here looking at the relative positions there of those two things? It starts what? So is it ahead or behind? It's ahead. So is it cycle then? If it's ahead by pi over 3, is it cycle starting from the 3 o'clock position, starting before or after the pedal? Does its cycle start before or after? So here is a cycle starting. Is it starting before or after the pedal? Here's where the valve is starting its cycle, and now the pedal is starting its cycle. Does the valve start its cycle before or after the pedal? Before. So if that angle is ahead by pi over 3, then it's starting its cycle before the pedal. So let's see how that plays out in the graph. So we're doing sine, right? So pedal graph. We know what the pedal graph looks like? Just the sine, right? And then I can put that same graph over to the right. So here's just the pedal, the vertical height of the pedal. And you told me if that angle is out ahead of it by pi over 3, that its cycle will start before. So if I put the pedal here, and I turn on the tire valve graph for its height, what are you going to see? What's that?
94.
Yeah, so it's already done pi over 3 of its cycle. It's already done pi over 3 of its cycle at this point when theta equals 0. So will its graph be shifted left or shifted right? It's already done pi over 3 of its cycle because it's ahead. It's ahead. Right? Do you see now when I start turning the pedal, the tire valve has already started. It's already accomplished pi over 3 of its cycle because it's ahead. It's ahead. Do you see the red graph as ahead of the blue one? Can you see it as ahead of it? Because theta increases from left to right. So it's starting its cycle pi over 3 before the cycle of the petal starts. Because it's ahead by pi over 3. And so it makes sense that by adding pi over 3, it shifts the graph left because it needs to start before the graph of sine theta. So when we talk about just all kinds of applications of sine and cosine, and we have these horizontal shifts in the graphs, this is the language we're going to use. Is the argument a larger angle or a smaller angle than the input angle? In this case, the argument is a larger angle, right? It's a larger angle measure. So therefore, it's ahead, right? It's ahead by that amount. And ahead means starting before, starting earlier, right? And so that means it's going to start further out to the left. So the graph is shifted left. And that's the language we'll use when we're modeling sine and cosine and have these horizontal shifts. Okay? Any questions on that? So, I mean, you've seen this the transformation stuff in previous math courses, and we just kind of memorized that if you add to the input, it shifts it left. But hopefully we're making sense of why that makes sense. That's our goal here. You're seeing that a bigger angle means coming ahead, means starting earlier. Therefore, shift to the left. Okay. So let's do an example here. I want to do this page. All right, let's see if we can write. Now we've got everything we need to write sine and cosine functions given the graph. Okay, so here's a graph. And the first thing we have to decide is, looking at this graph, does the period in a cycle relate to the pi scale, which I'm showing here? So the grid lines are showing a pi scale. Every grid line is pi over 4. Every vertical line is pi over 4. Or does this graph relate to a integer scale? 1, 2, 3, 4, 5, 6. So there's the integer scale. And then there's the pi scale. So I'll let you look at the pi scale for a second. Does the length of a cycle or the period relate to this pi scale, or does it relate to this integer scale? What do you think? You can see integer. Dan, what do you think? Integer. Can you see that this scale is what you're going to use to determine or visually pick off the period? What is the period? Period is an interval of input to get one full cycle. What distance of x values or horizontal values gives us one cycle? Jenna wants 2. What do you think? Agree with that? Yeah. Okay. So now let's talk about. So we got the right scale to think about here for this particular graph. It's going to be based on the integer scale because the period is 2, not 2 pi, not pi over 2, 2. Okay. All right, so the midline is the first thing we want to do. So all of our sine and cosine functions can be modeled like this, okay? And so the first thing we want to do is the midline. We want to get the middle of that graph in the right place. What is our midline for this one? Someone said -1. Agree? Sweet, okay? Amplitude. Remember what the amplitude was? Distance from the midline up to the top, to the max, or amplitude down to the min? What is it? Okay, now, so the period is not this value of b, but it helps us get this value of b, this coefficient. Okay, so our argument looks like this: bx or b theta or bt. Okay, so I'm using x here, so bx. Okay, where x is our angle measure, or it could be time. Who knows? All right, x is the input. So the argument bx has to attain. So we said the period is what? Period equals 2. So when that input reaches 2, in order to get a full cycle of output, we need that argument b times x to reach what? 2 pi. We talked about this, right? So we need what's going into cosine or sine to reach 2 pi in order to get a full cycle. And we know that's going to be when the input hits 2. So this tells us, therefore, we can get what b is. So we got b times 2 equals 2 pi, and that's the value of b that we need for this function, which is pi. Right? So our coefficient, this coefficient b, will be pi. So now, do we want to write it as a sine or a cosine? So we'll do the easy one first. So based on what you're looking at here, is it more streamlined to write it sine or cosine?
Sine.
Sine, because it adds 0, it's at the midline, and it heads up, right? We know that's our pattern for sine. So let's do sine. And with sine, we won't have any horizontal shift, right? We won't have any horizontal shift. So can you write the rule? So as a sine function, y equals what? Go. Can you do it? What's that? F of x, yeah. Nathan, tell me.
F of x equals 2 sine pi x minus 1.
What do you think? Agree with that? Midline's at -1, amplitude is 2. And if we had the value of x that would make this 2 pi is what? 2. And then we know that's right because that's our period, right? Okay, questions? Okay, so now we want to, so all of these, every graph that can be written as a sine can be written as a cosine. So now is where this understanding the horizontal shifts come in. So what we want to do is we want to sketch what it would be if it were cosine without any shift. So at 0, where does cosine without any shift start? The min, the midline, or the max? Max, and it goes to the, in 1 quarter cycle, it goes to the midline. Next quarter cycle, min. Next quarter cycle, midline. And we know the period is 2, so 1 full cycle, back to the max. All right, so I'm going to sketch cosine, best I can, without the shift. Okay, so there it is. So our graph, look for the closest version of that to make it easiest on yourself. The closest one. The closest kind of U shape like this, 1 cycle of cosine, is where? Here? Starting here, right? Starting here. So the graph that we want to graph, is it ahead or behind the graph of cosine without a shift? Behind. It comes later, right? It comes later. So we're going to subtract from the argument or add to the argument? Okay, so it's coming later. So is it angle ahead? Is the argument angle ahead of its normal cosine curve, or is its argument angle lagging behind? Lagging behind. So how do we get the argument to lag behind? Add or subtract? Subtract. Subtract how much? This much. We need to subtract that much so that our graph is lagging behind by that much of a normal cosine. Coming later, so its angle is behind. So what is that? 1/4, so this is basically 1/4 of 2, right? So how much is that? A half. So if we write this as a cosine, amplitude is the same. Now it's cosine. Pi is still what gets us the right period of 2. But now we need our curve is ahead or behind? Behind by how much? 1/2. And then the midline is the same. Did you catch it? Does it make sense? So our graph comes 1/2 units after, its cycle starts 1/2 units after. So its argument angle is lagging behind a normal cosine by 1/2. Make sure you get that in the parentheses, okay? If you do pi x, if you do this, it's not right. Okay? That's not right. That won't get it. You have to get that thing in parentheses, the way that we're approaching it, okay? So you guys are going to try one. I'm going to give you a curve. You're going to write it both as a sine and a cosine. You ready? Here we go. Let's see about this one. Beautiful. Okay, so first you guys will decide as a class. Do you want the pi scale for this, or do you want the integer scale? So right now it's on the integer scale. This is integer scale. So look at that for a second. Does it relate to integer scale? Okay, here's the pi scale. Does it relate to integer scale or this one, the pi scale? You see that its minimum here is at, what is that? At negative pi over 4. Its maximum is at, here's 3 pi over 4. And here's a minimum at 7 pi over 4. And then a maximum pi over 4 less than 3 pi. So this is relating to the pi scale, so I'll leave the pi scale up there. And your job is to write this as a cosine and as a sine. See how you do. I'll give you some time for this. Who can do it? This is kind of a harder one, right? So good practice. Right. Okay, what's our midline? 0.5. So let's see how we did here. Amplitude. Distance from the midline up to the top and down to the bottom. She got 3. Okay. What about the period? Jacob. So how can we're picking off the period? So what is period? What does it mean?
The amount of time that it takes to make one full rotation.
Interval of input to get one full cycle. So how can we figure out what that is?
Oh, well, it's 2 pi.
And how are you seeing that? How are you seeing that?
Because, well, I mean, just eyeballing the graph. It goes from about pi over 6 is where it starts, and then it ends at whatever.
Are you looking right here?
Yeah.
You're looking there, and then you're seeing that
It comes back across the x-axis.
the same distance past 2 pi.
Yeah.
So that's a little bit, that's okay, but it's not, say, as secure. That's kind of a not certain way to do that because you're saying, oh, it needs to be the same as that. So another way to do this is look at, say, this min right here. And when would the cycle start over? Next min. So that clearly looks like from there to there. Is from negative pi over 4 to 7 pi over 4. So the period is 2 pi, and so what's our value of b? Yeah, so we know that the period is already 2 pi for sine and cosine, so we don't need a coefficient. That's one way to argue it. Okay, that's one way to argue it. Or you can just say b times x needs to reach 2 pi when x reaches 2 pi. Therefore, b is 1. Okay, so who's going to help me here? Cecilia, you want to do sine or cosine?
Sine.
You want to do sine, okay. So how do we approach this? We want to write it as a sine. Our amplitude is 3. And our midline is?
1/5.
Add 1/2. So now, how did you figure out the shift for sine?
So I kind of went from the midline at 0.5, so I ignored these signs because I thought of that as the origin in a way.
Okay, right?
So b would still be 1 for the period, and I put x minus x minus 1.
X minus 1?
Yeah.
Okay, but this is not, so we're on a pi scale, so really these integers,
X minus pi over.
okay, why x minus pi over 4?
Because that would be the first.
So the way I recommend that you do this is sketch the sine curve without a shift. Which would be like this. And you were right to say on the midline, right? So on the midline. So it's going to be like this, 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 this. Let's try that first part again. Okay? Our graph of the sine that we want, so the graph that we are sine, is its angle ahead or behind of the graph of sine without a shift? Behind. It's coming later, right? It's coming later or behind. So add or subtract? How much? Pi over 4. So that's if you were to write it as a sine. How many people got it before I started doing it? How many people got that? Not enough. So does it make sense how you would do that? All right, so as a cosine then, Jenna.
So, beginning part is basically the same. 3 cosine,
Mm-hmm.
open parentheses, x minus 3 pi over 4.
Okay, so I'm about process, not about answers. Can you talk to me about how we get this? So you said 3 cosine of something. You're saying all this is the same, right?
Yep.
Okay, so now how are we gonna, what's our process to figure out how we're gonna shift it as a cosine?
Well, what I did was I used my graphing calculator to help me visualize it,
Mm-hmm.
but I realized that in order for it to line up, it would need to go pi over 2 earlier to the left.
Pi over 2?
Wait, no, wrong way. Yeah. You need to subtract pi over 2 further because the difference between a sine and cosine function is is pi over 2.
Oh, you just took, okay, so you just took the sine and you subtracted pi over 2 to get cosine.
Mm-hmm.
Okay, that's valid. So if we were starting from scratch here without the sine curve, how would we start? Allah, any idea? Okay, so what have I done? Yeah. Sketch the cosine without a shift. Sketch the cosine without a shift. Okay, and that starts at the max. And then at quarter cycle, it's the midline. And then half cycle, it's the min. And then back to the midline. Am I doing this right? 2 pi. So there's pi right there. Cosine. It's back to the min. There. Yep, so max and then quarter, pi over 2 to the midline. Pi, it's at the min. 3 pi over 2, it's at the midline. And then that. So can I do this here? Here's the same cosine, just without a shift. Okay? Faiz will take it from there. Or is that you? Yeah.
So graph I discussed is 9 by pi over 2.
Okay, what is this right here? Is that pi over 2?
Pi over 4.
Pi over 4? So here's pi over 2. This is pi. It's pi over 2. 3 pi over 4. Right? 3/4 pi. So the red graph is behind or ahead by 3 pi over 4? Behind. So the argument angle is less or greater? Less. Does it make sense? So there are other ways to do it. So you could have done, look at this. What about this? You could have done this for cosine. This, if we started with this cycle, I don't have a scale over here. So this is pi over 4, 1, 2, 3. This is pi. So this is negative 5 pi over 4 here. So this cycle, starting here, is 5 pi over 4. Ahead or behind? Ahead, right? This one's ahead by 5 pi over 4. So we could have also written it as 3 cosine x plus 5 pi over 4 plus a half. That's valid too. Okay? Because you could start with this other cycle over here and say, oh, this is starting way earlier than this one. Actually, 5 pi over 4 earlier than a typical cosine. So its angle is 5 pi over 4 ahead. Yeah. Anybody have a question? Okay, so now I'm going to give you a situation, and you have to come up with the graph, and then the function definition. So this is a good little project here. So you have to come up with the graph, and then from the graph, after you've sketched the graph correctly, then write the function definition. Work together. Here we go. Oh, sorry. You need that information, don't you? There you go. this angle, but we're doing the function. It's a function of the gear. You see? So this is going to be. Remember, we're doing the bucket height as a function of the gear angle measure. So what can you get? So you need to get the min, and the midline, the max, and the period. And you can sketch this. All you need is the min, midline, max and min, midline, and period to sketch this. Did you get it? Zero. Yeah, so all right, because what's wrong? Because it says when the gear starts turning, that's when the bucket's in the top. When the gear starts turning, that's when the bucket's at the top. Now we just need to have the period, then we can do it. Okay, so hopefully we got the max and the min. That's easy. We got the max and min. What's the midline? Okay, good. So that's, and then all we need left is the period. Who has a way to reason out what the period is? What's the period? It's the interval of input to give us a full cycle of output. So the input relates to which? The gear or the wheel? Gear. The output relates to the which? The gear or the wheel? Wheel. So we got to figure out what interval of the gear angle gives us a full cycle on the bucket. Who came up with something for this? Sean, is that no? I didn't?
No, I think I did. I think I messed up, so.
Okay. Do you can correct it now that you know that it's not right?
No, I'm very lost.
Very lost. How can we get the period? Andrew?
Well, I got one part of the field, which is correct, but I basically multiplied 2 pi by 2/3.
Okay.
2 revolutions to the wheel over 2 revolutions to the gear.
So is the period of the wheel shorter or longer than the gear? So the period of the wheel, is it longer or shorter than, say, 2 pi for the gear?
The
Yeah.
period of the gear is shorter than the period.
Okay, so how are we going to get this period of the wheel? Or period, sorry, the period of this function.
Well, I don't know if this is right or not, but the way that I was kind of thinking about it is if the wheel makes 2 revolutions,
Mhm.
you relate that to 2 pi,
Okay,
and saying that he makes 2 revolutions for every 2 pi. So I guess that for every 1 revolution, he would make 1 revolution, 1 pi.
no, not quite. Yeah,
Isn't it just 2 divided
2 pi divided by
by
5? 6? How can we reason about this? This is kind of tricky, yeah, Carlo.
I did, for every 2 revolutions, there's 3 revolutions the gear makes.
Okay, so 2 revolutions of the
Of the
wheel.
There's 3 revolutions of the gear.
There's 3 revolutions of the gear, okay.
So that's 2 over 3. That's what, period of thing, you can convert that to 2 pi. So times by 3 divided by 2. So
Yeah, Faisal.
Don't just multiply 2/3 multiply by 2 pi.
Times 2 pi. Is that right? So we get 4 pi over 3. Is that less or greater than 2 pi? That's less than 2 pi, meaning, so the wheel makes its full period before the gear does. Is it right? That's what that's saying. So if the period of the gear is 2 pi, then the wheel is going to make it around before the gear does. Is it right? The gear makes 3 revolutions, the wheel makes 2 revolutions. Is the wheel turning slower or faster than the gear? Slower. So its period going to be less or greater? Period is the interval of input to get a full cycle of output. So if the wheel is turning slower than the gear, we saw this with the bike and the tire valve, right? So when the wheel was turning slower than the pedal, what about the period for the wheel? Longer or shorter than the pedal? Remember that? Longer. So this isn't right because this is a shorter period. Anybody else want to give it a shot? So let's talk about radians. So when the, say, 1 revolution of the wheel is, would you agree, 1.5 revolutions of the gear? And so when the wheel goes 2 pi radians, the gear goes 3 pi radians. Did you agree with that? And so what is and our gear angle is our input. So what's the interval of input that gives a full cycle of output? What's the interval of the gear angle that gives us a full cycle for the wheel? 3 pi. Did you catch it? So I got 1 revolution of the wheel is 2 pi radians is the same as 1.5 revolutions of the gear, which is 3 pi radians. Well, that's telling us the period of gear angle, so that's the interval of the gear angle that would give us 1 full rotation of the wheel.
So you can go 2/3 of the radians.
What's that?
You can go 2/3 of the radians.
No, we're done. Period is 2 pi. So you'd have to take 2. What? Yeah.
The period is 2 pi.
What's that?
The period is 2 pi.
No, sorry. The period is 3 pi. Sorry, I misspoke. I misspoke at the end. Sorry, I misspoke at the end. We want the interval of input that gets a full cycle of output. Well, here's our full cycle of output. The wheel making 2 pi radians of rotation. here's the interval of input that does that, 3 pi radians. So there is our period is going to be 3 pi. Anybody have another way to reason about this? So now if we, yeah, please.
So there's another way. So I thought it was, so instead of 2/3, it's 3/2 multiplied by 2 pi.
Yeah, so somehow it's 3, exactly. Somehow it's 3/2 times 2 pi. So why does that work? What?
Because, for every 3 revolutions, you get 2 revolutions. And so it's like when you get the period, you just do it the other way.
So how do we know it's not 2/3 of 2 pi? So how is it? Because we know that's not right. So how do we know it's 3/2 of 2 pi and not 2/3 of 2 pi? Well, one way we know that this can't, like the way we said before, this can't be right, because we know our period has to be greater than 2 pi. Because when the gear goes around once, the wheel has not made it around yet. And we need that wheel to make it a full cycle. So it can't be the one that's less than 2 pi. Anyway, let's move on. So now can you sketch it and write it as a sine and a cosine? So here's our period, 3 pi. Here's our period, 3 pi. And you want to, according to the information given, you want to sketch the graph and then write it as a sine and write it as a cosine. You got the min and the max, and you got the period, and then you know where you're starting. Is your starting point going to be at the min, midline, or max? According to the info. Does it start at the max or the midline or the min? So we're still doing the graph. We're still doing part A. A bucket on the wheel starts where? At the top of the wheel. Where? How many feet above the water is the meters above the water is that? 5 meters above the water. So it's going to start at the min, midline, or max? Max. When the gear starts turning, 0, theta equals 0, the bucket is at the high point. And so then when theta reaches 3 pi, where will the bucket be? Min, midline, or max? This is one cycle for the bucket. Okay, so then at 3/2 pi, it'll be at the min. 3/4 pi, 3 pi over 4, midline. And then this one, what is that, 2 pi, 9 pi over 4? Where is it? 9 pi over 4, right there. Okay, so then we can make our sketch and we can write it as a sine and as a cosine. Go. So now it's just like the problems we had earlier in class. Can you write this as a sine and as a cosine? Now that you have the graph. Go. Or should we already have it? Is that why there's no activity? How's it coming? Okay, where did I lose you? Okay. What's that? Okay, well, so can we make some progress at least a little bit here? So we want to start with a sine function, or let's make it easier ourselves. It's easier, sine or cosine. Sine's going to need a shift, right? Cosine, we can just do it as a cosine without a shift because it's starting at max, right? That's our cosine. Right, so that's midline. So here's our strategy again. Here's our strategy. Given the curve, write the formula. Midline, amplitude. Find V from the period. And then you choose. Start with the easier one. And then do the other one. How's it going, guys? Progress check? Readings. Right, so normally it would, but we're looking at so as far as the sine that's 3 pi over 4 pi, that's your sine. So we get the same. Right, but starting at 3 pi over 4 pi is not starting a sine cycle, so that starts by going down. Sine cycle starts in the midline going up. So we can describe that first and easier sine so let's do cosine first, it's easier. And then you need this, you guys need a focus there, you need to put a period. But normally you need to big times that. Because if you're looking at the period's not 2 pi, the period's not 3 pi. So they're just confused. Like, so like the sine period, then you go down. Right? But that'd be what I'm just being extrapolated. So that's just. So normally okay. Oh, okay. Well, let's change anything. So the question is, does this correctly model the height of the bucket? So at A equals 0, it's at the top. Okay. And then suppose the gear is turning counterclockwise, right? So when the gear turns, so we're never just going to take 2 pi to get around. Whether it goes clockwise or counterclockwise, it's going to go max, midline, and midline max, regardless of what direction it goes back.
So you don't
Right? So this should be. But what you're doing now is you're writing a sine and cosine of that curve. Does that make sense? So as long as it's that curve, we know that's the height of the bucket over those 3 pi now.
Okay. So the period is the length of the interval. The usually is like instructions so like to multiply the input for the function by to get that. So for example, we got
So you're just, B's always like a ratio.
right. So when you're looking at the period, normally.
Okay, what's easier? So let's see. Midline. Freddie, did you get the midline?
Yeah.
2.
And solve for.
All right, see if we can do this, finish this one, and then do that other one. So midline is 2.
Right, but this time.
Amplitude.
Get it to the period, and then you have to somehow figure out what that number
3.
is on the inside of the argument.
Okay, so our period is what? Period is
So it's like going backwards.
3 pi. So now we need
So you're not saying that's how you solve for
we need to figure out what b is. So here's what we do.
what you need inside of that.
B times x, in order to reach one period, that argument has to be equal what? There's a question on the test like this. It's ask about the argument. What interval of the argument do you need to get one full period? What interval of the argument do you need to get one full period? What interval of the argument do you need? 2 pi, right? The success on this question is like 10%. 10% of students get this, and I'm telling you ahead of time. It asks you about the argument. It says, what interval of this argument do you need to get one full cycle? 2 pi, right? You set the interval, you set the argument equal to 2 pi. That's what the argument needs to do in order to get a full cycle. And so we want a full cycle to be when our input hits the period, which is 3 pi, right? So if we were to put in 3 pi, we need the argument to be 2 pi. And so we're asking what value of b does that. So b times 3 pi equals 2 pi, so b equals 2/3. That's the coefficient that will give us a period of 3 pi. Because when the input is 3 pi, then that argument will reach 2 pi and we'll get a cycle. So b is 2/3. Okay, so what's easier, cosine or sine? Notice, we are writing a vertical height, but we're using a cosine to do it. Are you okay with that? Because we've got the height profile correct here in this graph. We can write this as a cosine or a sine, regardless of the fact that it's measuring a height quantity in the problem. We can still use a cosine to model it because we have this curve, right? The curve. So we're going to do cosine first. We got 3 times cosine. We got our b, 2/3, x. No shift. If you're doing a cosine, it's no shift, plus 2. Does it make sense? Okay, so yes, the output quantity is a height in the real world. And yes, we're using a cosine to write that function. Is it okay? Is that okay? Or is that uncomfortable? Right? But the fact is that we created the graph correctly to show the height of this thing. Why? It's because the bucket's starting at 12 o'clock, not 3 o'clock. You see? The bucket starts at 12. And so it's going to start at the max, and then go to the mid, and then the mid, and then the mid, and then the max. That profile follows the profile of cosine with no shift. Okay? So it's make sure the graph matches the situation, and then make sure your function matches the graph. And then you don't have to worry about, oh, it's height, so it's got to be sine. No, it can be cosine also. Yeah.
So how would you write it if you wanted to write it as a sine?
We're going to do it. Let's do it. So we want to write it as a sine. What do we do first? It's going to be the same amplitude, same coefficient for the period, same midline. But now we're going to have a shift. So what do we do first to help us with that? Draw a sine without a shift. Hopefully we've done that all day, so hopefully that's draw a sine without a shift. There's sine without a shift. Okay? So, is our graph ahead or behind, and by how much? So here, our graph, you can see that it's ahead. Right? If we go from, like, say, starting with this max right here of ours, we can use our graph is coming ahead. Its max is, and how far is that? 3 pi over 4, right? It's starting 3 pi over 4 ahead of our graph. So, sine of, so is the angle larger or smaller? Yeah, so it's going to be a larger angle because it's coming ahead. It's ahead of. So it's a greater angle. So x plus 3 pi over 4. Okay, any questions on this example? Is it getting better? These are hard, but we gotta do them. All right, so want to do the Weber problem? Questions about this one?
Why is this one ahead instead of behind?
But the red one is sine. Ours is the black one. So its cycle starts before. So talking about the cycle starting at the max. That's a little confusing. So looking at this being the starting point of the cycle, the max, this one comes before, so it's ahead. And that's the one we're trying to do. So it's plus 3 pi over 4.